Hello, this is Steve.C, and today I'm going to go over actually all of the derivative shortcuts that I've talked about, and also one more actually. But I kind of want to compile all of them because they're kind of all spread out across different videos, so I feel like it would be good to go across. Sorry. I was just driving for a long time, so I kind of lost my voice a little bit. But the first one, obviously, this is the easiest one. I'm going to start with the multiple derivatives. There's two of them that you'll see on exams. Well, I've seen them on exams, practice exams, tests for AP Calculus. But the first one I'm going to talk about is talking about the nth, let me see if I do this right, yeah, dy over dxn of e to the ax, where a is a constant, right? You can just prove this using chain rule, where let's just do it once. So the first derivative is going to be take out the derivative of this, so it's going to be a, and then just leave this left over, e to the ax, right? And since a is a constant, we're just going to keep taking out a. So it's just going to end up a to the power of n, e to the ax. And sometimes they'll give you like differential equations where you got to do this, like it'll be like y plus y prime or something like that. And it'll say like what value of k, where like e to the, I don't know, e to the kx, what value of k makes it true or something. That's the kind of questions that they like to ask. Other ones are, this one is a little bit more difficult, but if you know your trig rules, it's pretty easy. We're talking about sine and cosine. And I can go through the proof quickly, but here, I'm just going to write this out. dny over dxn of, I'll only do sine x. I'm going to explain the proof really quick. All you need to know is that sine x is equal to e to the ix minus e to the negative ix over 2I. The 2I can come out, so it's like 1 over 2I times e to the ix minus e to the negative ix. And then you use the nth e to the ax rule with I and negative I. You get you get a logarithm of an imaginary number, but it actually works out pretty nicely to be, let's choose a marker, sine x, well, sine of x plus n pi over 2. And it's cyclical, so technically there's like a plus 2n pi, but that doesn't really matter in this case. Oop, almost just lost that. And it's the same thing with cosine. It's just cosine x equals cosine x plus n pi over 2. So those are the nth derivative ones, and they really like to ask you, like, and with the chain rule also, it does the same thing that the e to the ax did, just takes the constant out every single time. But those were the nth derivative ones that might be useful. So now I'm going to go to the just quick instant derivative rules. First up, there we go, that's a little bit better. I'm going to talk about, let's see, which one should I do first? I completely forgot them. I'll do, ln. I'll talk about ln of f of x. Whoops, this is my favorite one because I'll show you. Ln, I'll use this marker, ln of f of x, and we're looking for the derivative with respect to, oh, that was terrible. I need that dx looked like an m. Anyways, the derivative with respect to x of the natural log of f of x. Right now, I'm just going to tell you it's equal to f prime of x over f of x, but I'll show you why. Okay. Yeah, I'll do this one again. So first of all, I'm going to set up a little bit of a chain rule. So outside function is ln of x. Inside function is f of x. Derivative of ln of x is 1 over x. Derivative of f of x is f prime of x. So then we just do our normal chain rule. Composition here, so 1 over f of x times f prime of x will go to that. So that's why that one works. Okay. And also with this one, you can prove the derivatives, the integrals, the antiderivatives of like cotangent, I think. Because, for example, if I wanted to find the derivative of, I can't remember if it's positive or negative cotangent, ln of sine x. Off the top of my head, I don't remember what this is, but I can look at this and say, all right, inverse derivative of sine is cosine. Yep, cosine x over sine x. So that equals cotangent x, right? So using this, you can actually really easily check, is this the antiderivative of this? And it is. Same thing with cosine, but cosine will give you negative tangent. Now, next one I'll do. I like all of these. These are all really fun. Some function f of x times e to the x is equal to e to the x times whatever the function is plus its derivative. Like this. And whew, that was fast. And I'll explain this one also. I have no idea if this marker works. I'm just trying to get in some variety. So this is just product rule, f of x. That's nice. F prime of x, e to the x, and e to the x. Put these together, we get e to the x, f prime of x, plus e to the x, f of x. And commutative property, it doesn't really matter where it goes, f of x. You can factor out the e to the x. And also, because again, commutative property, I just did it in a different order. It's going to be the same, f prime of x plus f of x. These are the same thing, right? This one, also super easy. And actually, what I'm working on right now is finding the nth derivative of x to the n e to the x. It has some really cool patterns in there. So maybe I'll do that before I leave, because I'm going on vacation in like a week, so I'm putting together a bunch of videos before then. Next up, I'll do not falling over. That would be great. I'm going to do the other e one, the derivative of e to the f of x. This one, very similar to the e to the ax, but instead it's just f of x. And you can actually prove that with this, because that's what it's going to become is f prime of x e to the f of x. This is actually useful in a very specific case. But first, I'm going to show you how this works. Now, you can probably look at it and tell, but I'm still going to show you e to the x, f of x, and f prime of x. Right? Composition, e to the f of x, product, f prime of x. This is just chain rule. So put these together and multiply by that. And that's how you get there. I'm going through these quick because I want to give like just one quick overview of all of these. Next up, I'm going to show you how that's useful. I'll just use the green. Right, so if we know the derivative of e to the f of x is equal to that f prime of x e to the f of x, that's really helpful from when we're looking for the derivative of x to the x, which is just very special, because I'll just go through this problem. This is actually a very cool example of what we call logarithmic differentiation, where I'm going to say x is equal to e to the ln of x. So it's going to become x to the x is equal to x. No, I'm going to do e to the ln of x to the x. I did it backwards because these are equivalent. And because of our log rules, I can say that's going to be e to the x ln x. Now, x ln x, what's that derivative? Because I can just plug it into this formula now. Well, I'm just going to say we have our x and we have our ln of x. I'm just going to set up a product rule. That's 1. Yeah, that's 1 over x. I was doing all sorts of weird stuff there. So that's going to be 1. These multiplied gives us 1. Plus 1 times ln of x is ln of x. So either way, I like to write this ln of x plus 1. So I can actually say this is equal to ln of x plus 1. And e to the x ln x, which is equal to x to the x. So that's actually a really cool way you can use that to make that go really quick. Now, last but not least, and this is probably the most useful, I'm going to show you a cool one. I actually just came up with this the other day because I was like, there has to be something here, and it's pretty simple. I'm going to look at just Okay, we're going to do this again. Okay, we're looking at the derivative of a reciprocal 1 over f of x. And off the top of my head, I think it's like negative f prime of x, I think, over f of x squared. This is actually where we can get quotient rule from. We can use this too, because no one likes the limit definition of derivatives, I hope. But I'll just show you how we get this, because this one's also pretty useful. Watch me get this wrong, because this one's newer for me. So I'm going to start with 1 over x, which is x to the negative 1. And also the input of there is going to be f of x. This is just another chain rule. So the derivative of that is negative x to the negative 2, which is equal to negative 1 over x squared. Okay? And then obviously the derivative of f of x is f prime of x. Composition, so we're going to end up with negative something over composition, f of x squared, so f of x squared times f prime of x. Bam. Those go together really well. And then also, if you really wanted to, you could prove the product rule using or quotient rule using the product rule actually with that. So keeping that in mind, let's see what I'm at. Yeah, I'll do it quickly. I got time. So what I'm going to do here is I'm going to say I have I'm looking for the derivative of, this is just like a cool exercise, f of x divided by g of x. And what I'm going to say is I'm going to have f of x times 1 over g of x. Okay? F of x, its derivative is just f prime of x. 1 over g of x's derivative is going to be negative g prime of x over g squared of x. G of x squared. Okay. Now product rule this together. I'm not even going to do that. We get, my brain just stopped. Oh, yeah. We get f prime. No, we start here. F prime of x over g of x minus, yeah, I haven't actually written this out. I see where this is going. This is going to work. F of x, and oops, I did the minus because normally it would be plus, but I have a subtraction there. Minus f of x, g of x, a g prime of x, over g squared of x, right? Now, just simplifying fractions, we'll multiply this side by g of x. So we're going to end up with the product with the quotient rule. F prime of x, multiply that by g of x to make it equivalent, minus f of x, g prime of x, all over g of x squared. It's pretty cool, right? All right. So hopefully that was helpful having all of those in one place, and also some examples where they're pretty useful. But this was Deep Thoughts with Deegan. That's the end of this video. Thank you for watching.